In this section, we will discuss Chebyshev's rule and the empirical rule. Once you understand the definition of a z-score, which we discussed in a different section, we can then begin to explore different rules which gives us additional insight into basic characteristics of data. Chebyshev's rule can be applied to any data set, regardless of the shape of the distribution of the data. This rule can be used to make statements about the percentage of data values that fall in different intervals. Specifically, Chebyshev's rule states that at least 1 minus 1 over k squared of the items in any data set will be within k standard deviations of the mean, where k is any value greater than 1. If we allow k to equal 2 and plug 2 into this basic definition of Chebyshev's rule, Chebyshev's rule would state at least 1 minus 1 over 2 squared, or 75% of the items in any data set will be within 2 standard deviations of the mean. If we plug k equals 3 into this equation, it would read at least 1 minus 1 over 3 squared of the items in any data set will be within 3 standard deviations of the mean, or at least 89% of the items will fall within 3 standard deviations of the mean. By inserting k equals 4 into this equation, Chebyshev's rule would read at least 1 minus 1 over 4 squared, or 94% of the items will fall within 4 standard deviations of the mean. We can apply Chebyshev's rule to different data sets. Suppose we have a data set with the sample mean value of 100 and a standard deviation of 10. We can use Chebyshev's rule to determine the percentage of data values that will fall in the interval 75 to 125. In order to apply Chebyshev's rule, we must determine what z-score interval the numbers 75 to 125 represent. In order to do this, we can compute the z-score for 75 and then compute the z-score for 125. Computing the z-score for 75 using our z-score formula, the z-score is 75, the value that we want the z-score for, minus the mean, which is 100, divided by the standard deviation, which is 10. This gives us a z-score of negative 2.5. When we compute our z-score for 125, we use the z-score formula. 125, the value we want the z-score for, minus the mean, which is 100, divided by the standard deviation, which is 10. This gives us a z-score value of 2.5. Since 75 is 2.5 standard deviations below the mean, and 125 is 2.5 standard deviations above the mean, we can say that the interval 75 to 125 represents all values that are within 2.5 standard deviations of the mean. Therefore, our k value in Chebyshev's rule is 2.5. Chebyshev's rule states that 1 minus 1 over 2.5 squared of our values, or 84% of our data values, will fall within 2.5 standard deviations of the mean. In other words, at least 84% of the data values in our data set will fall between 75 and 125. Let's apply Chebyshev's rule to a different example. Suppose we have a data set with a mean of 70 and a standard deviation of 4. What percentage of data values in the set will fall within the interval 65 to 75? In order to apply Chebyshev's rule, we must determine the z-score interval that 65 to 75 defines. In order to do this, we compute the z-score for 65 and obtain negative 1.25, and we compute the z-score for 75 and obtain positive 1.25. Since 65 is 1.25 standard deviations below the mean, and 75 is 1.25 standard deviations above the mean, the interval 65 to 75 defines all values within 1.25 standard deviations of the mean. Therefore, k equals 1.25 in Chebyshev's rule for us. Thus, at least 1 minus 1 over 1.25 squared, or 36%, of the data values will fall within 1.25 standard deviations of the mean. Or, at least 36% of the data values in our data set will fall between 65 and 75. Let's get some hands-on practice with applying Chebyshev's rule. Suppose we have a data set with a mean of 20 and a standard deviation of 5. What percentage of data values in the set will fall within the interval 7 to 33? You should pause the video at this time and try to complete this problem. For this problem, you should have computed the z-score for 7 as negative 2.6 and the z-score for 33 as positive 2.6. Therefore, the interval 7 to 33 defines being within 2.6 standard deviations of the mean. You should have used k equals 2.6 in Chebyshev's rule to find that at least 85% of the data values must fall between 7 and 33. For Chebyshev's rule, our intervals will always be symmetric about the mean. In other words, when you compute the z-score for the lower and the upper limit, you will always get the negative and positive values of the same number. The empirical rule. The empirical rule is applicable to data which is normally distributed. Normally distributed data is often referred to as data that has a bell-shaped distribution. The empirical rule can be used to make statements about the proportion of data values that must fall within a specified number of standard deviations from the mean. If a population has a mean mu and standard deviation sigma, and it is described by a normal curve, then the following rules will apply. 68.26% of the measurements in the population will fall within 1 standard deviation of the mean. 95.44% of the values in the data set will fall within 2 standard deviations of the mean. And 99.73%, or almost everything, all values within the data set, will fall within 3 standard deviations of the mean. In Chapter 6, when we explore the normal distributions, we will understand how they computed the percentages presented on this slide. For now, let's focus on applying the empirical rule. Suppose we have a data set with a mean of 20 and a standard deviation of 5. Furthermore, we are told that our data set is normally distributed. What percentage of data values in the set will fall within the interval 10 to 30? First, since our data set is normally distributed, we should use the empirical rule instead of using Chebyshev's rule. The empirical rule will give us a much more precise percentage estimate. We have to start by determining the z-score interval in which the data values 10 to 30 describe. When we compute the z-score for the number 10, we obtain a z-score of -2. When we compute the z-score for the data value 30, we obtain a z-score of +2. Therefore, the interval 10 to 30 defines all data values that fall within 2 standard deviations of the mean. According to the empirical rule, 95.44% of the data values in a normally distributed data set will fall within 2 standard deviations of the mean. Or in our case, 95.44% of the data values in this data set will fall within the interval 10 and 30. Let's get some hands-on practice applying the empirical rule. Suppose you have a data set with a mean of 60 and a standard deviation of 7. Furthermore, you are told that your data set is normally distributed. What percentage of data values in the set will fall within the interval 39 to 81? You should pause the video at this time and try to answer this question. You should have began by computing the z-score for 39 and obtained -3, and 81 and obtained a z-score of +3. This means that the interval 39 to 81 defines all data values that are within 3 standard deviations of the mean. The empirical rule tells us that 99.73% of the data values in a normally distributed data set will fall within 3 standard deviations of the mean. Therefore, for our problem, 99.73% of the data values for this data set will fall between the values 10 and 30.